Non-destructive examination, or NDE, is a group of analysis techniques used to evaluate the integrity of materials, components, or systems without causing damage to the material you're testing. NDE is a great method for reducing costs, ensuring safety, and building confidence. NDE has become widely accepted as a cost-saving technique in the quality process because it allows inspection while a tube is in service, enabling problems to be detected, repaired, or replaced before they fail. NDE ensures safety by monitoring the integrity of materials throughout the life cycle of the product. The mission statement of the American Society of Non-Destructive Testing, ASNT, is to create a safer world by promoting the profession and technologies of non-destructive testing. Selecting the proper NDE method or combination of methods can provide the peace of mind that any imperfections detected in testing are small enough that they do not impair the reliability of the product. Here's Dan Janikowski with some expert advice on ASTM standards and ASME codes when it comes to NDE.
ASTM standards and ASME codes provide for a very basic level of non-destructive testing. Unless specified, tubular products will have either an eddy current test based on a relatively large drill hole or a hydro test. Both of these tests are insufficient for detecting imperfections that may impact reliability of the product. Supplemental tests, such as more stringent eddy current testing, ultrasonic testing, and leak testing, can be ordered to ensure that the tube manufacturer is detecting and rejecting much smaller imperfections. You may also remove the ability for visual inspection to override the NDE results, which currently is allowed by ASTM and ASME standards. This allows for higher resolution in-service testing as part of an ongoing reliability program. Special NDT is important in critical applications involving high cycle fatigue like hydraulic control systems and other applications where a small leak could result in a catastrophic failure.
All products should be produced to the relevant ASTM standards and ASME codes. For testing purposes, ASTM defines artificial defects, which are used as the rejection criteria for each test. The most common artificial defects allowed are drilled holes less than 0.031 inches in diameter. Tubes with defects smaller than this would not be rejected. Additionally, each technique is sensitive primarily to the defects in one specific direction. These artificial defects may allow smaller real defects to pass. These real defects can impact product reliability and performance. Most ASTM tubular product specifications mandate a single NDE test. The specifications allow for a single non-destructive electric test or hydrostatic testing, but neither are mandatory. This means the producer has the option to perform one or none of these tests at their discretion. The methods for non-destructive electric testing on tubular products include eddy current testing, or ECT, ultrasonic testing, or UT, and hydro testing. The eddy current test is the most common NDE testing method, mostly due to the speed that the test can be administered, as well as its relatively low cost to perform. The ASTM standard eddy current test for tubing uses a differential technique for detecting defects, which is most sensitive to detecting very short, abrupt defects in material. Circumferential defects will most likely be detected in ECT. The standard ECT tests are the A-1016 and A450, base .031 drilled hole standard. ECT may not identify large defects, which can gradually develop along the length of the tube. Because the ECT test is fast and less expensive than other methods, it's the predominant NDE choice for testing, tubing, and smaller diameter pipe. Optional, more stringent ECT tests include the ASTM A-688S1 and S2 tests, which require using longitudinal and transverse OD and ID notches as the acceptance criteria. The S1 and S2 tests also include additional special requirements, such as calibration every 30 minutes, instead of every 4 hours as the normal A-1016 test requires, meaning they will take longer to perform. The ultrasonic testing, or UT method, sends a focused sound wave called a shear wave into the wall of the tube and then detects the echo that is reflected back to indicate any imperfections. It is normally performed by sending the sound wave in a circumferential direction around the tube. Angular defects may reflect the sound wave differently, so the tube should be tested in both directions. Unlike differential eddy current testing, UT testing is most sensitive to longitudinal straight defects such as cracks and incomplete welds. However, ultrasonic testing takes longer to perform, making it comparatively more expensive than eddy current testing. A hydro test is performed to check for any leakage in the tubing before it is shipped. It is a safe and commonly accepted approach to test pipelines or tubing for leaks. In this type of test, the tube is filled completely with water, one end sealed, and the tube is pressurized from the opposite end. The tubing is pressurized to a specified pressure greater than normal operating pressure, and the test pressure is held and the material is inspected for leaks for a specified amount of time. Other common pressure tests include air underwater and pressure differential tests. Both are much more sensitive than the hydro test for small leaks. In many cases, it is important and beneficial to move the inspection processes beyond the basic general standard test requirements.